So yeah, this is going to be your series here. Now, to get this behemoth of a series back, all you need to do is to further integrate it. So you get tan x to be equal to the integral of this thing, 1 plus x squared plus 2 by 3 x raised to 1 plus x squared plus 2 by 3 x raised to 4 plus so on and so forth dx. So if you integrate that, you will get this as x. This is x cubed by 3. This is 2 by 3 into 5, x raised to 5, plus so on and so forth. So, like I said, this is an expansion because you can't get the further terms. All of these are going to be random as terms. You cannot predict what the next thing is. So tan x, you get as x plus x cubed by 3 plus 2 by 15 x raised to 15, x raised to 5, and so on and so forth. Now that took way long. I think it's much more easier to do that with Maclaurin. Anyways, now as a final bonus, let's take a look at another series that sometimes you have to come across when you play around with the limits. Okay, so that function is going to be f of x is equivalent to 1 plus x the whole raised to 1 by x. Okay, so like I said, I haven't tried expanding this using Maclaurin, but if you use binomial theorem, it's going to be a bit more simpler. Well, it's not binomial theorem technically, and let's see. First, what I'll be doing is that I'll be taking the log of both of this on both sides. Log of the function. I'm tired of writing this as f of x. Let me write this as some y. Okay, so log of y is equal to, this thing comes down, 1 by x, and this will be log 1 plus x. Look at this bad boy right here. We have already derived this guy using our binomial right here. That is the application of binomial. That's the power of binomial, damn theorem. Let's go. So, what is log 1 plus x? We know the series. It is x minus x squared by 2 plus x cubed by 3 minus x raised to 4 by 4, so on and so forth, up to infinity. Now, if you put the x inside here, x and x get cancelled. This is 1 minus x by 2 plus x squared by 3 minus x raised to 3 by 4, plus so on and so forth. Now look at this right here, my friends. Log of y. What is y? What is y again? Y is our function. So to get back y, all we need to do is to take, to raise it to the power of e. So bear with me here. What I'll be doing is, all right, y is equal to e raised to 1 minus x by 2 plus x squared by 3 minus x cubed by 4, so on and so forth. Now, I'll be doing some little tweaks here so that we get the form that we generally need when we're dealing with the limits problems. So, I'm going to treat this thing and these things separately. Okay, so I'm going to write this again. Y is equal to e raised to 1. That is the first thing. And then, this is not GIV, okay? This is a general bracket. Plus the bracket minus x by 2 plus x squared by 3 minus x raised to 3 by 4 plus so on and so forth, like this. So we know that this plus right here can also be written as a raised to x into a raised to y is equal to a raised to x plus y. So I'm going to reverse this here. So this thing I can write as y is equal to e raised to 1 is e into e raised to minus x by 2 plus x squared by 3 minus x raised to 3 by 4, plus so on and so forth. Now, this guy over here, I'm going to use the series expansion that we had derived for e raised to x prior to this. This is again also going to be, you guessed it, an approximate series, because in place of x we have another infinite series, but we've already dealt with infinite series in binomial expansions before with tan x, so we're not afraid of it anymore. Let's bravely face it and finally get the series that we need. So e, and this we know, I'm going to write it down here, e raised to x is 1 plus x by 1 factorial plus x squared by 2 factorial plus x cubed by 3 factorial, so on and so forth. So e here, and then times, multiply that with, instead of x, this series. So first term is going to be 1 plus, in place of x, what do we have in place of x? This thing. So minus x by 2 plus x squared by 3 minus x raised to 3 by 4. That whole thing, so on and so forth is there. I'm not going to say that every single time. It's kind of tireful. Anyway, divided by 1 factorial plus minus x by 2 plus x squared by 3, so on and so forth. The whole squared divided by 2 factorial plus etc. etc. So again, we only need the first couple of terms here. Y is equal to e times 1 minus. These terms are small fries. You know, there's nothing too crazy going on over here, so let me write them down. Now this, we're going to do the same thing that we did before with tan x. We're going to take only the smallest person from here. That is minus x by 2 plus x squared by 3, so on and so forth, multiplied by the same thing. What do you get? Minus and minus becomes plus. This is x squared. This is 4. So x squared by 4. Rest of the terms, we don't care about them right now. So we're not going to talk about x cubed and so forth. Okay? The third power and onwards, we're not going to talk about it. So this thing becomes only the first term we took, that is plus x squared by 4, divided by a 2 factorial is there from here, and then plus some etc. 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 In other words, oh shit, can't turn the page. Hold on. Y is equivalent to e times 1 minus x by 2 plus x squared by 3. We're going to disregard x cubed, okay? So from our second term, we got it as x squared divided by 4 into 2 factorial, which is just x squared by 8. So we get a plus x squared by 8. Okay? So now what we'll be doing is we'll be combining both of these terms here. So this will be an etc. here. So e times 1 minus x by 2 plus this is just 11x squared divided by 24 plus so on and so forth, right? And now, ladies and gentlemen, we know that y was our f of x itself, so it's 1 plus x to the whole raised to 1 by x. This is a series that you might come across a bit, and this is how you derive the series expansion, at least for up to x squared, I guess, for that. Okay? So yeah, this is a little bonus expression for you. I hope you were able to, understand the method that I was trying to convey to you. Now, it is a bit long, I'd say, so I had to cut it into 3 parts because I couldn't upload it as one giant video. But yeah, I hope this helps. Yeah, that's about it. Thanks.